Hello, today we're looking at Leetcode problem number 2294, partition array such that maximum difference is k. So in this problem, we are given an integer array nums and integer value k. So now what this problem is saying is that we have to partition the input into subsequences and return the minimum number of subsequences needed such that the difference between the subsequence min and max is lesser than or equal to k. Okay, now this is sort of similar to a problem that we looked earlier, which was 2966, where given an input array, we had to partition that into arrays of length 3 and array of length 3, and one of the things that we had to take care was the minimum and the maximum have a difference of lesser than or equal to k. Now, in this problem, our child array that we're generating can be longer than 3. Okay, and this is a variable. It can be of any size. Okay, it depends upon the problem. We keep growing this as long as the difference between any two elements in this array is lesser than or equal to k. And I also explained this in the previous problem, but what happens is that if you want the difference between any two elements to be lesser than or equal to k, that means we have to satisfy this condition for the worst case, which is this has to satisfy for our min and max, right? So if our min and max, if the difference is lesser than or equal to k, then any other difference in this range is obviously going to be lesser than k. So this is the thing that we have to satisfy. Now, if we think about um, handling this problem as it is, which is the unsorted array, then what we would do is probably find a lowest number in this array, let's say 1, and then keep scanning one by one for all the numbers that are lesser than or equal to k from this particular minimum. So we will look for um, other numbers and we'll keep doing this. Make sure is there any number that we are adding here, the difference between that and the minimum is this condition is satisfied. And then um, once we have scanned the whole list, we know that there is no other element which with the difference lesser than or equal to k. Then we can look at the next smallest element that is remaining in this list. So now, if you think about what we are doing is, let's say my minimum is an element of value e. Then what we are doing is we are making sure that we are covering all values which are with the difference of lesser than k, which means the maximum value that we're going to take up is e plus k. And when I go to the next list, this is going to continue from where we are leaving here. Okay, so if I'm doing this operation and if I'm doing the way that I've told you, I am scanning the whole list multiple times for every element that I'm adding, and so this is going to be out of an operation. But if we want to make this better, what we can do is we can take a greedy approach and we can sort our nums. Once we sort it, actually let's continue with this example. Once we sort our num, what we're going to say is we will have two pointers, okay, which is the start and the end of the list that we're trying to generate. And we keep moving the end pointer one by one, and we keep checking the difference with this. Now, the advantage that we have with this kind of a approach is that once we reach a point where the condition fails, which is that it starts to become greater, the difference starts to become greater than k, then if it has failed for this, it will fail for all values greater than this. So we don't process the elements greater than that, and that's how it becomes more efficient. Okay, so the sorting technique is the key to this problem. Other than that, it's not very difficult. So let's quickly run to the pseudocode. So let's say I first sort my input, and then I say that my start is equal to num sorted of 0. And one very important thing which I think I forgot to mention is that we don't need to return these subsequences. All we need to return is the count that we have two subsequences generated. Alright, so I will have a variable here, say subsequences count. Okay, we start with 1 by default because if we have an array and if this whole array falls within the difference of k, well and good, we have 1. If we split, one split means we have created 2. So for every operation that we will take, we will always get 1 extra. So what I was saying before I got disconnected was that the reason why we have count of 1 here is because let's say we have an array where the difference between every element with every other element is lesser than or equal to k, then we have one array at the very least. Now, if I partition this once, what I get is 2 arrays. So for every operation that I'm doing, there is 1 extra that I need to count, which would get missed. So I start with 1. Alright, so next step, we look at element by element. Okay, so first we are here and then we look at here. So this is the progression that we are making. Okay, so for element in nums sorted, now we check if element is greater than my start plus k. Okay, so if this has happened, then what we say is that this particular element, or rather in this example of this slash, this particular element that you're looking at has a greater than k difference with the start. So this becomes our first subsequence, and then we are going to start a next subsequence. We don't know where that would end, but let's at least do the counting. So we say subsequence count plus equal to 1, and we also increment our start now. So start is equal to this new element, and finally we return our subsequence count. That's about it for this problem. Again, the time complexity is defined by the sorting, so it's n log n here.